Thank you, JS Daddy, for that. So today's lesson is very simple and it's very short actually, because we'll be dealing with the AI development workflow as the screen leads. And basically here we'll be checking on how to uh, how do you make sure that every part of your AI model it's well aligned with our Ubuntu standards. Okay. Remember we said in Ubuntu, we leave no man behind, especially in the village. Because if you leave a man behind, the village might stay hungry because that man will steal. We don't trust them. We got trust issues. So they've got to go together. We've got to go together and be the warriors. Yeah, in the forest. Face the giants in the forest. Yeah, because if we leave a man behind, yeah, it's gonna be that man. You are tempting him to be a thief. Okay? Yes. So we don't wanna that. We don't wanna do that. Okay? Yes. Yes, there is one time there was a war and King David was left behind. I don't know why a king would be. In those days, it was mandatory for kings to go to war. But unfortunately, that day King David was left behind and bad things happened. First, he saw a lady taking a bath. He was in his palace just taking a rest. And then I don't know if he just started scoping his eyes. He started conversing already, and his eyes spotted already. Oh my. And a lot of hair happened after that. You get? Yes. So mostly when you leave a man behind, a lot of hair happens afterwards. Okay? Yes. Yes. Cool. So we leave no man behind. So we'll be checking on AI development workflow. Now, guys, for those who have issues with enrollment, just do just please enroll like Nuri. There was an update that only allows you to see one module of specialization that was performed on the RMS. That is what affected, because the why it was done is to also allow those members who are it. There are some of you who did not specialize when we are doing specialization. So like they did specialization later. So what happened is that some of that update could have happened or affected your progress. Worry not, just enroll and continue. Just ignore it. Okay. Yes, 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 nothing serious. Just trying to make sure that in the spirit of Ubuntu, we are also not leaving anybody behind, even as we specialize. Okay, cool. So that said, let's go for the rest of the day. So, my dear, we are in week 5, meaning in week 5, guys, we've done a lot. We've learned a lot. So if you've just joined, you'll have a few series of catch-ups to do because we've really done a lot. Okay, we've really done a lot. We've done vibe coding. We've done a lot of tooling. We've specialized the tools. We've gone through the tools of AI. We've done AI for software engineering. Yes, and we've also done machine learning paradigms. So like we've really covered a lot. And actually, to be honest, after today's lesson, you are in a capacity now, you should be in a capacity to undertake an AI project from 0 to 100. because after today, we'll have covered, we'll like have finalized every aspect you need to understand about AI. Actually, if you check the next lesson, week 6 is about ethics, week 7 is future, week 8 is we want to see the projects you'll be working on. Okay. Yes. So basically, that's why I'm telling you, kinda we've finalized. Yeah, the syllabus is moving too fast, eh? Yes. So now you should start thinking about your final project. And the beauty of final project, it has two ways of being submitted. You can do your final project as a group. That is the first option, the most encouraged one. Do the final project as a group, because a group, mostly from history, we've seen group works being more better and more better. Okay. But that does not mean group works are always the best. Okay. So you can also, if you feel you have a very good project, you want to deliver alone as an individual, well and good. Go ahead and work on it and deliver. Okay. Yes. So next lesson, that is on Monday, JS Daddy will share with us the final project, final, not my words, final project submission form. You will start submitting your final projects. Now that form, you just submit a final project, a functional project, okay? So from now, you have, by week 8, you should be done with most of the work of final project, because yeah, you will have, by week 8, we will be completing 16 weeks, 18 weeks actually, because you are added 2 more weeks to help you guide on specialization. So there might be no more time added, because not unless maybe you request, but mostly if all goes well, I don't think there is any time that will be added to you guys. So start working on your final project, okay? Yes, start working on your final project. And let me highlight this. I think this is very important. The previous cohort that was before you, the best guy, the best male project, and the best female project, final project, were from AI. Okay, I think you should clap for us guys. We did a lot of work, guys. Huh? Yeah, they were AI projects. So the pace has already been set. Please do not drop that bar. Do not drop that bar. Make sure that you keep the bar up high, that your projects emerge as the best. We want the winner of I think, Evans, it's $100. Is it $100,000 or $10,000? I think $10,000, eh?
When you convert, should be, last time it was 100,000 Kenya shillings, but I don't know the
Uh-huh.
price.
Uh-huh.
Yeah.
Yeah, you see, so the last time I saw somebody being given $12,000 for free, just because they had a nice project. Why not be you? Think of that. Just free money for doing what you are supposed to be doing. Hmm? Okay, cool. All right. So we just know that we made quite good progress. All right, let's continue now. So AI workflow, as the name suggests, is all about how should an AI project be done? That's the question we are answering today. So if I were to do an AI project, where would I start? Okay. Yes. So this is where you would start. So the first thing you would do correct your data. Okay, make sure you do a nice communal harvest that your model can use. All right, just like the way when you want to eat, you make sure you have a good harvest and you have nice storage where you can be keeping the food. All right. After that, do something we call data pre-processing, cleaning the village square. Why? Because if you don't clean the storage house, rats and gnats will really mess up the food and the village will be hungry. Okay, so you need to clean the data and to make sure that that data is in order, is in the right order. Okay, we call that data pre-processing. Then we have model selection, whereby this is more like choosing the village elders. Now, once you have the resources input, you need guidance on how to use those resources. Okay, so that's like when you are doing model selection. Okay, because also in a village, you need guidance on how to work with resources that are available so that we don't get some people misusing the village resources. All right, and then we need model training. This is fireside apprenticeship. The fireside apprenticeship is whereby you expect before model goes out to perform, you just have to rehearse, just like the way in a village folk dance, you have to harmonize these voices so that when we sing and the dance moments come and the party moments comes, then everybody, the harmony will be as sweet as the voices from Pangoni. All right? Yes. Yeah. Then we have model evaluation. Evaluation is where you test your model to check how is it working based on the problem that you've trained it to solve. How accurate is it? All right? Yes, mostly we say the results being, because it's probability, they should be between 0 to 1. So the final result should be very close to 1 or 1. 1 means fully accurate. And the more it's very close to 0, it means very close to inaccuracy. Okay. So you have to go to Gotila Court, whereby at Gotila Court, you want to make sure that if somebody have done a mess, then they are very much accountable for their mess. All right. And finally, we have model deployment, where you have to return the gift to the village. Okay. Yes, you don't return to the village without a gift. Nice. Yes, so that's what we'll cover today. Cool. So let's start with data correcting. Data correction. Yes, so you do the communal harvest, single hand, gather the whole harvest, cannot gather the whole harvest. Okay. So what we mean is that you need to get your data set right. You need to get your data set right. And what we mean here, your action plan is to make sure that you correct diverse data, whereby you match your data. Let's say you wanted to correct data about food, corn, for example, corn growing or corn farming, all right? You have to correct right data about the soil, the seeds, the weather, the weather data that is needed, or because not corn cannot grow in any weather. Corn does not grow in icy areas. Okay, yes, so you have to know which weather conditions support corn growing. Cool. which soil support corn growing, which type of manure to apply, all right, which types, how many varieties of corn can you grow, maybe based on the available soil. Cool. Yeah, so you need to correct your data well. Correct it, ensure it's diverse. Why? Because you cannot expect to work well with data that is limited. Actually, if you do that, your model will suffer from what we call overfitting, meaning it cannot be able to run from new data. All right, cool. So you need to do that. After that, ensure there is ethical sourcing. What do we mean by ethical sourcing? You never get to extract, meaning you partner with communities. You partner, you make sure that you identify the sources of your data. Where did you get your data? It's very important because data comes from somewhere. It doesn't exist in the air, it comes from somewhere. So make sure if you corrected the data in the village, I corrected the data in village, house number 1, from Mr. Osanto and Mrs. Andego and Madam Kadaiga and Erda Matiango. Those are the data sources. Simple. You've informed us where you got your data, all right? Or if you have got the data from a third party, make sure you credit, share the benefits, make them known. Say, for example, you corrected data from, you didn't correct the data from your village, you corrected from the village of Gadiango. You make sure you say, I corrected this data from Gadiango. It was already available for them. Okay, yes. So that is how you go about it. So if you use third party data like cargo data sets, make sure you credit them. But this is data, I corrected it from cargo data set, and it deals with this, it was corrected by this and this, between this period and this period. We make sure you share the benefits of that. So that's pretty cool. And after that, make sure yeah, do not spoil our broth. You know, if you don't do diverse data correction, it means that you will serve as, it's like inviting a village for a party, and then you only serve modokoi, modokoi alone as the only meal. There is no busa, there is no Moratina, you know, there is no the variety of Ingoho, you know, there is no the variety of Omusupe, you know, we need those things. Fufu, you know, yeah, you can't call a party by and then serve one main dish. No, no, you don't do that. You don't do that. All right, so that's cool. The next thing you do, you make sure you correct data pre-processing. We do the cleaning of the village. So before the feast, we sweep the grounds together. Why? Because you need those people who come to dance. If they find our grounds are not clean, they won't be able to dance because you can't dance on a dirty ground. Okay, so we clean the village square. So how do we do that? We clean the village square by one, um, making sure that we handle missing values of any data. All right. Yes. So handling missing values, and that's what we call data cleaning. Okay. Yes. And then you make sure that if there is any data that is not correct, you correct it. So you check on inconsistencies, you check on data anomalies, you correct them. Cool. And then you do something we call numerizing. normalizing. So when you normalize, it means you do what called data wrangling. Data wrangling is making sure that your data is in line with the standards you've set for your model. Cool. Yeah. And then you make sure that there is harmony. This is like making sure there is harmony in our music. You don't want people to do music and then there is no harmony. No, you have to clean the voices, clean the altos. You have to hear the baritones, the soprano. You need to hear bass one, bass two. The oohs, the vibe. You need to hear the yeah, yeah. You need to make that music feel nice. Okay, cool, nice. That is very good. All right, that's it. Then we get to the third part. The third part is model selection. Now, in model selection is basically making sure that you have the right elders advising the village. Okay, for example, you want Mzee Utosi, who knows much about all the women in the village. So if there is a young man who needs to marry, we go to Mzee Utosi because he will tell us about all the women in the village. All right? Yes. And then there is Mzee Ukwana, who knows all about the behavior, the behavior of all the men in the village. So when we want our new girl to get married, we go to Ukwana because Mama Ukwana is good. Mom Ukwana, Mzee Ukwana, Mama Ukwana. Yes, and then after going to Mama Ukwana, we also want to go to Mzee Ugato, who is very good at negotiations. Okay, dowry negotiations, so that our boy does not suffer from being made poor because of no repayment. Okay. Yes. So you have to find those wazees who have the wisdom and the know-how of how these things work in the village. Okay. Yes. So and wisdom lies in choosing the right guide for the journey. So this is where you get to match the tools to the task. Like you say, use logistic regression for simple decisions and deep planning for complex patterns. And again, make sure that you are able to query which model serves your, which, for example, tool or algorithm that you choose serves your model light. Okay. Yes, because you don't want arrogance. Yes, you don't want to hear when we go to dowry payment. You don't want Mzee Utosi to be saying, I told you that Gary is not good for you. If he says that, there will be no beer for the women. And things might go south. Things might go south. All right? Yes, you don't want to pour the beer. No, 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 no. You don't do that. Okay, yeah, so you can see the elders there. There they are. So if you want visualizations, you choose Matplotlib. Okay. Yeah, we have elder regression for logistics, Matplotlib for visualization, deep planning for complex patterns. Good. Thanks. Then next, we've selected your model. You'd have to train your model. You don't want in a dance where we are supposed to be raising our hands, okay? And then Ochora, the dance leader, is raising his legs. Haita baba. It won't be funny. It won't be nice. It won't be good. Yeah, and peradventure on that day, his hidden clothes somehow happen not to hide anything. I tell you, it will be chaotic. It will be chaotic. You don't want that. You don't want that. You don't want that. So, yeah, so you don't want that. So you have to train your data model very well. All right. And the action plan, make sure you handle the iterative learning as what do we mean by iterative learning? The loops. A loop is something that is done over and over, an action that you want to be done over and over. Make sure you handle them fast because those are the ones that will keep repeating. So you need to assess the small steps that this is we've made small progress here. That small step is called an epoch, okay? Or an epoch or epoch. You call it whatever you want. And then you also check on course corrections, those error fixings you have to do as you progress. There are errors that you have to do to we saw that in the morning. There are errors you have to fix as you progress. Those errors you have to fix as you progress, they are called backprop. Not backprop, it should be backdrops. Yeah, mostly I think the right word is backdrop. Yes, yeah, it should be called a backdrop. So I think I'll edit there. Once you get I'll edit before I share. I think I'll edit backdrops. So you have to check on the small steps, progress, epochs versus the backdrops. Yes, a backdrop is that error that you encounter as you test the model, and then you need to ensure that you correct it. Then you prevent overfitting. Why? Because a child who only knows one village cannot navigate the world. Yes, so make sure that your data is diverse. Your model can learn diverse. It can be able to overcome a few issues. Okay, that's why, for example, your model, you use try, and you can be able to use the try and set. Okay, so for example, you try something. If it fails, then you tell it, have this, you can pass this option. Okay, yes. So that is how it should work. Yes, and some of the metrics you can use are dropout metrics or regularization metrics. Dropouts metric is a metric that checks when an unintended action does not happen. What should happen next? Should the system just stop working? Maybe because we expected something to happen at some point and it didn't happen. All right. Yeah. So you also apply regularization to ensure that through regularization, your every sequence is executed. All right. Yes. And very good example is in the student libel, lowering loss bar. So if let's do the limbo challenge. The limbo challenge is a good one. We did it in the morning, and in the morning I got a few people who said they will join me and JS Daddy as we go for Ribo. The Ribo errors here, we are checking how low can we, how low can the model work with list data, okay? Like which is the list data available that our model can work with, okay? And how low should the standards be for our model to work, Okay, so we go for the lowest. Why? Because if it can do with the lowest, even on the highest, it can be able to perform better. Okay, yes. So let's do the rainbow here. Let's see how we gotta do the rainbow. The rainbow. Oh, yeah. Oh, cool. You see how cool is the rainbow game? Is that cool? Cool, very cool. And you see, for her, she has won all the world records for being very good at Limbo. Yeah, so you want your good model to be like Shilisti. Yeah, okay. Yes, it can work well at very low, with very low conditions, and even when the conditions are set high. Cool. Nice. I hope I get more people to join me for Rimbo this weekend. Kwani, what do you guys do on the weekends? Aye. Yes, after we visit State House, we go for Rimbo. Cool. Nice. All right. That's very nice. Um, model evaluation. Uh, Now this is testing. How good is your model working? Okay. Yeah. So basically, is checking, is the model doing what we wanted it to do? Okay. So you test fairly. Make sure that you go beyond accuracy. You check on beyond accuracy. What else do you check? You check on the precision. Um, how can it, how precise is your model? Okay, yes, it's accurate, yes, but how precise is it? Okay, precision is key. This is where we check the speed. How much time has it taken to do what it is doing? Recall, can it be able to like undo an issue, an error, or go beyond an error? Recall, you get? And we also have another metric we call F1 score to check how much time did it use to execute uh, a task precisely in a very good manner. All right? Yes. So how is it easy to execute? That's when we are talking of records. And how is it efficient? We got F1 score check. Bias check. Does the AI lift all the voices? So there you can apply confusion matrices to spot silence groups so that you don't have data that is being harbored by the model, but it is not useful. Okay? Yes. So again, it's think of it like calling for justice in the village. Okay? Yes. And like for example, you can see there Mzee Msenelo was found guilty of stealing mkombel from Mama Nyariaka. Huh? Now, and you see, he has to explain himself. Why did he take mkombero from Mama Nyariaka? Huh? And yeah, so you check which is the false positive and which is the false negative, and which one harms the village more. Okay, cool. Hmm? So that is it. That is it. And finally, but not least, you do model deployment. Okay. Yes, model deployment. You can do your model deployment. Think of it of the way to return to the village with a very nice gift. And you can see the women are happy. If the women in the village are not happy, nobody will be happy in that village. I tell you the truth. Yes. Eh, try. You cannot prove me wrong. I'm telling you the truth. Yes, you better take this one from Elder Chakin. If the women in that village are not happy, everybody else will be sad. Okay? Yes. So first, don't seek to please the men, seek to please the women. Yes. Nice. Cool. Yes. Yes. Hmm? As you can remember in the Bible, there was a time women were so happy about King David, and they started singing about how King David have killed tens and tens of thousands. Mm-hmm. Yes. That was returning David as a gift. I'm telling you, the trouble that befell him afterward. Ho ho ho, oh ho. It comes with a price. Making women happy comes with a price. It's one of the hardest job you can ever do. Try. Ask David. Cool. So basically, in deployment, you monitor and iterate. You deploy and check, is the work done? So it should be making sure that check whether the work has been done. If it has not been done, track the drift. Where do we have some weather changes? Where are we having some gaps? All right. And then use that as feedback. Okay. And then also correct feedback from the users of the model. Deploy it for if the model was supposed to check on weather parameters, just check, use it to measure weather parameters. And if it is not working, it's not working. So take the feedback groups. So let's users speak, their stories refine the AI. So the more people tell you about feedback about AI, the more you can be able to work around it and refine it better. Okay? And then you perform maintenance. What is maintenance? Maintenance is review of the AI application for updates. That is some new functionalities, patches, some new fixes of errors, which we called backdrops. Okay? Yes. And some upgrades when you want to bring not only new functionalities, but to add new modules. Okay? Yes. We call that an upgrade because beyond functionality, you want to bring up like to add, maybe to extend the application now, not only to manage village A data, but village A, B, C, D, you get? Yeah, something of the sort. All right. Yes. So Yes, so each successful prediction triggers a drum sound, and we all celebrate we celebrate it as a corrective impact. Okay. Yes, so that is what ensues deployment. So basically, we have a very nice Ubuntu summary, of all we've talked around. Okay. And then a very nice summary of what we've talked about. So it's all about first, you correct the data. After correcting the data, with that data, you have to do data pre-processing, and then model selection, and then model training, and then model evaluation, and finally model deployment. After that, you say, hooray, I'm an AI developer. Awesome. Oh, that guy looks nice. Yes. And I think that's the end. Any query? Any questions? Somebody's hand was up somewhere. I think they stopped raising their head. It's okay. If there's no query, JS Daddy, you are ready? We go for the model. For the model?
Yeah,
Yeah.
yeah,
Okay.
I'm ready. I'm ready.
Okay. All right. Thank you. That's
I'm ready
okay.
for Monday.
Let me stop sharing. That's cool. Take over.
Yeah, yeah, I'm sharing my screen. Just give me a second. Uh-huh. Which screen should I share? Yeah, there we go. Do. And I hope you guys can clearly see my LMS, can clearly see my code.
Yes,
Yeah,
we can.
yeah, thank you. Thank you guys. I hope you are well. I hope you are ready for the demo. And I hope you had a good day as well. On my side, I'm well. But before we start the session, I just saw something interesting I wanted to show you. There is this coding agent. It's from Google, so it's something that you can trust. It's from google.com. It's called Jules. It's called Jules. It's a coding AI agent where you can just connect to your Google, then not Google, but your GitHub. Then once you connect to your GitHub, you can import a repo. And in that repository, you can tell it to do whatever you want to do. If you get the desired outputs or changes, then you can accept. Just as simple as that. It's a coding agents. We call them AI agents. So you can check it out, Jules. It's called Jules. Let me just share here. You can check it out. It's a good one. It will help you in your development journey. Anyway, let's get into the practical part of today. So we want to check at these steps here. These few steps. These steps Jakin shared. That is data collection, model training, model evaluation, data processing, then model selection, and all the way to model deployment. So we are going to check at these steps from data collection, data processing, model selection, model training, model evaluation, and deployment to the cloud. So we are going to check at some code. that I prepared for you so that you can check it out as we explain what's happening. So the code is already here on the LMS. You don't have to worry much about it. So everything is right here. So you don't have to worry. Yeah, it's very simple. It's very simple. So let's get started. So the goal for today is to do some few tasks. For example, assume that you have an e-commerce website where your clients are giving feedback. So in this feedback that you are getting, you want to evaluate, is it a positive feedback or is it a negative feedback? So that's what we want to basically achieve. Okay, so basically that's we want to achieve. So over here we have some few data. So let me just go to the code on the other side. Oops. Anyway, ignore this. So so we have this data. We have this data. Let me do with that line of code. So we have these reviews, customer reviews, and they are in form of sentiments, either positive or negative. So each product review or each customer review is different from the other customer review. For example, a customer said, I love this product. Another customer said, this is the worst product I've ever bought. Another customer say, this product is not worth my money. I highly recommend this product. Now, let's assume that we have this data in large quantities now. This is just a small quantity of data. Now, we can just use pandas, first of all, to format our data. Remember which process we are following: data collection, data processing, model selection. We are following this procedure. So we have to take any data, clean the data, train the data, and deploy that particular product. First step, we have the data here, the raw data, very shaggy data, unorganized data. So we can assume this variable here, then we pass this review. So this is just a dictionary. You know, this is a dictionary in Python. So over here, in this dictionary, we have our first item in the list, that is the review and the sentiments. So in the list of reviews, we know this is a list in Python. So in this list, we have a list of reviews. So in this list of reviews, and we have the sentiments. We just have the data, clean format for a good looking data. So we create a data frame. Data frame, we can just call it a table or whatever you want to call it, just an organized data that we can read. So we create a data frame. This is just a normal variable that you can name it in any way that you want. You can just name it in any way you want. So this is a data frame where we use the pandas library that we imported on top of here. Then we use this data frame, pandas.data frame. So in pandas, we have this data frame method here, or this function here, that will help us to create the frame or to organize the data. Then we pass the data that we want to pass over here. Now assume this is a very large list of data. So we pass the data frame here. Then we can print out the data frame. So what have we done? What have we achieved? We have collected information. Then we have formatted it for better processing. Okay? We have formatted it for better processing. So what step have we done? Data collection, and some of the processing and preparation. So we have done this preparation, data collection and preparation. So once we run this cell, we have our data that has been organized. You see, this is an organized data set. It's now no longer just a normal data. It's an organized data. So step one, tick, achieved very well without any problem. That's a tick. Now we can see we have organized. I love this product, it's a positive. The worst product, negative. A very good fast delivery, positive. So these are, or this is an organized data. Step one, achieved without no problem. Let's go to step two, data processing or model selection. So let's see what our next step does. So our next step here is basically, this is just like downloading more data. This is just a step of downloading more data. And this more data, we are doing more operations. That is the data processing. So now let's assume we had okay. Now let's assume we had a different data set, or we want to work with a different data set. We said this data can be ugly as possible. So in this next step, we want to do an extra activity. You want to prepare our data so that our AI can understand. First of all, we need to tokenize our data. We need to add things like stop words. So in this case, we are going to use the NLTK library. So in this NLTK library, inside it, we want to use, or we want to download the stop words. This is a data set that is already there, stop words. Then we want to also use the word tokenizer. So in this case, we want to tokenize words. For that, our AI can understand. Also in our data set, we just don't want our data to be in any format. Some other data are numbers, strings, boolean, things like that. We want it to have a good format. Either we want to convert our data to be clean, to be a string, or something else. So we import the string right here. And now remember, we have two different data sets here that we can compare from. The stop words that we download from the NLTK. So this is a built-in data set that we can download. So there's nowhere that we are going to download this data. We are downloading it automatically from the NLTK library, built-in data set. Otherwise, in case you want to do with your own stop words, you can go to the Kaggle data sets, then download any data set of your choice, depending with the goal that you want to achieve, then replace this data set here. Replace basically this data set. Good. Up to there, we have these stop words. We are going to see what they are doing. And this other data set, that is the PanKit or the PanKT. So we have downloaded this data set. Remember, our end goal is to maybe assume we have a very large data set and we want to load it to our AI. So we download these stop words. Okay. So the next step is basically doing the pre-processing function, creating the pre-processing function. So in this pre-processing function, we just define a function, very simple function. And this function is, we call it pre-process text. So in this text, what are we trying to do? Remember our end goal, which stage are we at? data collection, data processing. So we want to make sure that our data looks clean, formatted. It's just a standard data that we can feed our AI and doesn't have so much pain while it's trying to train or while it's trying to compute the output. So that's the end goal. That's what we are still doing here. So our data set that we just downloaded, we convert our data set into lowercase. So we take the text, we just define a variable text, then we convert the text to lowercase. Okay. Why are we converting this? Maybe in our data set can be having one in uppercase, lowercase, blah, 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 all that kind of information. It's not clean. The next thing that we can do into our data set, after we remove the lowercase letters, you also need to do what? To remove the punctuations. The punctuations can be the comma, exclamation mark, full stop, all those kind of punctuations that you can do to a statement. The next is just removing those punctuations. So we just define a variable text, and text, we pass the text variable that we pass here, dot translate. So once we translate this, we are doing what? We are doing away with the punctuation. So basically this is going to take the punctuation mark, replace it with a string. Okay, and make it a string, make it understandable. So basically we are removing these characters, these special characters that you see here. We are basically removing these sample characters here, all these are punctuations. So we convert that into a string, right? Now it can be understandable. Fine, cool. Now, after we punctuate or we remove the punctuation, we do what? We do tokenization. In this tokenization, we want to make sure that our text, our numbers are well tokenized for a machine to understand. These machines don't understand any word, they understand tokenized data. So basically we are doing what? We define a variable tokens, then we pass it to the word tokenizer. So it's going to check the words that we just formatted. We remove the punctuation and we formatted into lowercase. Now it's going to do what? To tokenize everything with the word tokenize. Remember this word tokenize, we imported it right here. It's nothing new. We imported it here from the NLTK library. So it's nothing new. So we transform that text into tokens. So we remember which words we are converting to tokens. The words that we just removed the punctuation marks and we made it a lowercase. Then we can remove the stop words. First step, lowercase, remove punctuations, tokenize, then remove the stop words in the tokenized data. Now, how do we go about that? So we stop words, every stop words, we set that into English, the language. You can set this into Chinese. You can set this to, what are the common languages in Nigeria? I don't know any. I just know you can change this into the Ogas language. I don't know which language. This you can change this into Luo, whatever language of your choice. Then after that, now we can pass everything that has been formatted with the above formulas. Then we can now create the final tokens. Now over here, we just create a small loop. In this small loop, is going to loop all through these other steps that we did. So for a simple word in forward, take a simple word forward in tokens. Only this if word is not in stop word. So if any word is not in stop words, then do what? Convert into tokens, then join each single token, whatever token, one token, two, whichever tokens that you have tokenized. Now join all the tokens. Which tokens? The ones that you just changed into lowercase, the ones that you just remove the punctuations, combine them right here. Remember everything that you tokenized. Now join every single thing. In context, this is what we are doing. Now, just a simple with this example here. You see this, we have uppercase, we have lowercase, we have exclamation mark. So this is not clean, right? We remove this, we replace to I, small I, lowercase I. We remove the punctuation. Then we take everything that we have removed. Remember that we have worked on this independently, this independently, this independently, this independently. Now, whatever we are doing right here below is basically joining everything that we just worked on. Then after that, basically, you create a simple data frame. You just create a simple data frame. So basically this code is same as basically this one here. Remember what? We just create a simple data frame. Remember we worked with this example. Now what if we work with another example here? So we just create a simple data frame. So our data frame, we have client review, the new frame, client review. We assign this to the review that you have made. Then apply. Basically take the review, apply the new changes. Basically just take this review, apply the new changes. Which changes have you made? Lowercase, removing the punctuations, tokenizing, adding the stop words. Then just apply everything right here. Then of course, now you can print out the output. As simple as that. Very simple. Was that easy or was that hard before we continue? Was that explanation easy? If it was hard, you can tell me, yeah, it's fine. People are saying, yeah, thumbs up. Very fine, very fine, very fine. Very simple. Yes, it's okay. Understood perfectly. Now you see we are building on top of something. We are building on something now. Data collection. We collected the data. We processed the data. We tokenized it. Very simple. Now let's go to the model selection. What is model selection? Let's see. Let's see what we have in the model selection. So the model selection right here. Now we are going to combine all those steps and see how it works. So let me show you now, combining the two steps above, and we try to do everything. Now, you remember something like this in the code above, where we downloaded the stop words and the pankit. You remember something like that? You remember when we are using pandas to create data frame? When we converted everything to string? You remember when we were importing stop words? Just in the code above, just in this code here. Imagine I just copied this code and brought it here. It's just like combining the first step, second step, third step. Now we are choosing the model. So this one we already imported. Whatever we have added here, it's very small thing. The model selection. And in that case, we are using the sklearn, the scikit-learn model. Okay, we just added the scikit-learn model here. Why are we adding the scikit-learn model? We shall see. So we just add the scikit-learn. So in this scikit-learn model, we want to take the vectorizer. We are going to see what is vectorizer. Then in the model selection, we are going to take the model that is going to do the training, testing, and the splitting. So train, test, split. Which model in specific are we working with? The linear model. So in the linear model, we're going to take the logistic regression. So this is what we just added in the above code. Go to scikit-learn, take the vectorizer. We are going to see what vectorizer is doing. The scikit-learn model selection, the model selection, we are going to make sure in our model is going to do train, test, split. Then the specific model to do that is logistic regression. Okay. Actually, we are downloading the data here, nothing new. We just took the NLTK, downloaded the pankit in the stopwords. So in that case, this one is just similar thing. It's just a similar thing. You remember this in the first steps here. Just a review. So it's basically, where is it? It's basically the same. Nothing has changed at all. The same thing. Then we create a data frame for this. We basically create a data frame for this. Nothing has changed. So we are taking this data, we put it into the processor. You remember this processor? Remember this processor? This processor is the same processor that we added here. Our processor did what? Converted everything to lowercase, punctuated, tokenized, added stopwords, then joined everything. Remember that process? It's the same process right here. The preprocessed text. Convert that into lowercase, but in this case, we have added an extra layer of code. That is try exempt, just to catch any error. In case we face any error in between our process, we are catching it right here. So let me re-explain. So basically this works as if our code executes to true, then print out the output. Else, the error. So basically this is if else statement. So in the if statement, we have if it executes to true, print out the output. If we have an error here and it's not true, then print out the output. Try exempt. So try this. If we have any error, exempt the error. Show us the exact error we are facing. So convert that data into lowercase. Remove the punctuations. Tokenize, the same process that we just did above. Add stopwords. Then combine now the tokens. Then join each single tokens. Now join one by one tokens, then get the final tokens. Okay, very simple steps. But in case we face any error, use the exemption error. And the exemption error is going to show us which specific problem are we getting. Are we getting a problem in converting to lowercase? Are we getting a problem in translating? Are we getting a problem in tokenization? Or are we getting a problem in the stopwords? Or are we getting a problem when joining? So this one will try to get a specific, that specific detailed error where we are getting the problem. Now after that, now you can apply the function. Basically, we create a data frame, the cleaned review now. Then we assign that into the review. We replace that into the review. Then basically that apply, basically append. Just insert inside it, just apply that. So in this review, we are going to apply what? We are going to apply the process. So let me explain this. What is this doing? You remember, you see this process that we did here, tokenizing, doing everything here. So basically you want to take this review, reinforce to follow those, basically to follow those rules, to tokenize and add the processes. Basically that's what we are trying to basically apply here. Let's define a clean review. And in this clean review, the final clean review will be take the review or take the reviews, then reinforce it to what? To follow these rules. Apply this function. Basically like that. Then after we assign it, we can print out the output. As simple as it looks. So if we run this code, we can see we have these reviews. Then we did our reviews right here. Then in this review here, we can get the cleaned review. As you can see in the cleaned review, we are finding some few errors. Which errors are we getting? Remember that we did an exempt block here. That is catching the specific error. So according to what we have learned in Python previously, what error is this? Basically, this error tells us we have three statements to do review, 1, 2, 3, and in our case, that's correct, 1, 2, 3. Okay, 1, 2, 3. Then, where is it? So it's getting that. So it's trying to read the first review, but it can't read a new line. So it can basically read a new line. So we see we are getting the specific error. So that means it has successfully converted into lowercase, tokenized it, removed the punctuation, and rejoined everything. So basically the problem we are getting is just reading a new line. As simple as it looks. So if we try to run this several times and we try to see if it can run or read new line, then it can be able to catch those specific errors. So you see this is working perfectly. Apart from that, it's not reading a new line. Getting everything correctly as we would like it to get. Very simple as it looks like. Yeah, someone, yeah, Fanuel, you're saying nicely explained. Yeah, everything is just nicely explained here. Imagine what step have we done? What step have we done? What step have we done? We have done data collection, data processing. We selected the model. Just the step that we did was model selection. And we selected the sklearn to reinforce now these activities, tokenizing, punctuating, adding stop words, all those kind of steps. That's what we did right here in the model selection. So we can go to the next step, that is model training, and train our model now. So in our model training, we need to do some few things. We need to add the vectorizer. Then You're also going to do the model selection, the logistic regression. So basically, in case you wanted to add this code on basically this code, we could just have added the vectorizer, this line, this and this and this. So basically, we could have done away with this. So basically, we could just do that. So basically, in case you want to add that code, you can just copy this code. You can basically copy that code and just add it down here. Basically add it down here. Basically add it down there. Where is it? It should be, no, not here. It should be from here, converting this into vectorizer from here. Now, instead of adding it here, let's just explain with a simple cell, with just a simple cell, so that you see everything clearly in bits. You remember this vectorizer that we added here? This train test split, is it? This train test split and this logistic regression. Remember what we added here? Now let's make use of it. So we are creating a vectorizer, and the purpose of this is basically to do what? Convert text data to numerical features. What are numerical features? Numbers. So let's see what this code is doing so that we understand this statement. So we create a vectorizer. So in this vectorizer, so in case someone is asking what are these vectorizer, so let's just go back to high school and see vectors. Vectors. See what are vectors, for example. See what are vectors. I'm trying to get into simple mathematics. Let me just see the simplest mathematics. In simple squares. In simple squares, for example, calculating a vector. In case you understood mathematics, in case you just want to go back to mathematics and get what are vectors. But I'll show you. From what you understand, from mostly what you understand a vector looks like this. In case from what you understand, you remember a vector looks like this from what you understand from mathematics, simple mathematics. 0, 0, 1, 0, whatever numbers that you add in your vector. So mostly, for example, not vector, but this is matrix. Sorry, this is a matrix, not vectors. Vectors looks like this. Just calculating like a network, just a simple network. This is a matrix, sorry, but vectors is just like adding simple networks, joining the networks. So we add a vectorizer here, and in this vectorizer, so what are we trying to do in this vectorizer here? We create a variable x. So what is variable x? Variable x can be anything. It's not a must that is x and y. It can be anything. So it's up to you to define what you want to define here, the variable that you want to define. So we can just leave it as x. So in this in this x, we import the vectorizer dot fit transform. Now we are transforming this into a vector. We transforming what? The Clint review. Where are we getting the Clint review? Remember here. Remember where? Remember, let me do away with this so that you get the Clint review. So you remember here where we were trying to clean this. Then we got the cleaned review here. We defined this to cleaned review. So we want to use that cleaned review now. Transform that into, or vectorize it. Vectorize the cleaned review. So in the Y, we have the data frame, we pass the review. So let's split the data into training and testing sets. So we have the data to train, testing against the testing data sets. So we can pass the X train and the X test, Y train and Y test is equal to, we assign it to this particular function here. So we said, let me repeat for maybe someone who has ever missed, maybe someone has maybe missed our either of the classes. So assume the X and Y as an X and Y axis of a graph. Assume that as an X and Y axis of a graph. For example, this is the Y axis and this is the X axis. Now let's assume this is our set of data. This is just a triangle here with, not a triangle, but this rectangle here with X and Y axis. Just hold on that with that concept, transfer that concept to here into this AI. So we have the X train, the X test. So in the X axis, we have the X train data set, then the X test. We have the Y train data set and the Y test data set. So in that case, in the Y axis, we have the Y train and Y test, X train and the X tests. Maybe we want to draw a certain pattern. We shall see the pattern later. So with that same context, transfer it into this context of this AI. Now, in that case, we use the train test split to do what? To split our reviews and the cleaned review to what? Training and testing data sets. First, the training, we said in case you want to understand what are these, the train and test, we assume, let's first assume, we have a clean set of data that we are going to use it for testing. And on the other hand, we have the data that we are going to use to train with. Hold on that concept. Now let's transfer it to our context here. Now, we use the train test split our data into training and testing. Okay. We pass the data that we have vectorized here. The cleaned data we have vectorized here. Remember, it's our clean data. And the data that we want to train with is our test data, the data in our review. We want to review. So we pass the test size to 2%, 20%, train it into bits. 20%, we also allow it to have some deficit to avoid our data from overfitting or underfitting. We pass this into 20%. So basically we said, remember in our first sessions, when we are talking about transforming an image from a scale of 28 by 28, equate that into a scale of 1. It's just like transforming something from a scale of 28 by 28, then you equate it by 1 by 1. Like calculating the ratio of something, assign this is equal to 1. something like that. Now, you see this 0.2 is just like 20% of one test size. Then we pass the random state to 42. So this random state 42, you can assign it to 2 as long as it's a number between 1 and 100. 0 and 100. So basically this is like 42%. The random state here we pass to 42%. And imagine the next step is just now assigning our model. That was the logistic regression model. So we define our model to use the logistic regression. Then after we assign it to logistic regression, what are we going to do here? We are going to train our model. So we are going to model.feed is the training. We are going to train the X train and the Y train. We are going to train the Y and X train and the Y train. Basically like that, and we have trained our model. So let's see what we have achieved so far before we go to the final step. We just have one more step and then we call it off. So let's see what we have achieved. We collected our data, we cleaned it with pandas, we transformed it, we tokenized it, we did model selection, then we have trained our data. So remember our initial product was to review customer reviews. We collected the data, we processed the data, we assigned it into a model, we selected a model, now we are training the model. Let's evaluate the model. So what is the purpose of evaluation? To check, does this data have some errors? Does this data, is it predicting accurately? What is the accuracy? What is the loss rate? Is our model efficient? So that is the model evaluation and testing. Model evaluation and basically testing. So let's do that. So basically here, for us to clearly evaluate it, and test is basically simple. We use the scikit-learn library to calculate the metrics. The metrics is the mathematics. Basically, how accurate is it? So, in calculating the metrics or the mathematics side of it, what are we going to do? In that report, we want to get the classification report. And also we want to take the confusion matrix. So let's see what we want to achieve here. So basically we want to make our prediction on the test set. So basically we create a variable here. We can call it y_predict, y_prediction. So we take the model.predict. Predicting what? Remember what we did here. The model.predict. What are we trying to achieve here? Where are we getting the word model from? This is a variable that we are using here. So remember, this model is just this model variable here on top here. Remember, I said this is one piece of project that we are just breaking it into parts for you to understand. So we are just breaking it into small parts for you to understand what's going on. Very simple. So model.predict. Predict what? Predict the accuracy. How accurate is our model? Are we getting any problems? Is it overfitting or underfitting? things like that. So very simple. After we predict, now we can evaluate and get the mathematics part of it. So in the confusion matrix, you're going to get what? Pass the confusion matrix, y test and y predict. So we are going to use the trained data that is the y predict, then the y test. Remember, maybe we have an accurate data. So we are going to get the report for that. And also, we are going to get the final report, the classification report of y test against y predict. Y test against y predict. So we said in y test you can have the accurate information. Now you want to see from whatever we have trained, testing against this, how accurate is our model, and we get the report here. So if we run our code, oops, model is not defined, model is not defined. So let me just take it here. It should be up here, more up here. Let me run this cell. There we go, it's getting. So remember I said this is just one piece of code, nothing big here. It's just like taking this code here. So in that case, in case you wanted to test it, in this case here, you can define the model. Let me just call the model. The model is this one here. No, let me just copy this and just add it here. Let's see if it works. There we go. Yeah, it works. So you just call this model variable, call the logistic regression, then train it, then test it. And there we get our report. The confusion matrix is this one here. Then we get the detailed report. The detailed report. The detailed report is as it looks like. The accuracy is calculating the precision, the recall, the F1 score, and the support. So it's calculating the accuracy, in which our accuracy is 1. Very accurate. Our model has trained and predicted accurately. 1, remember this is 100%. The average is 1, good. The weight average is 1. Everything works perfectly as intended. There we go. And imagine you have done all the steps. The steps were data collection, data processing, model selection, model training, and model evaluation. So we have done all these steps successfully. The final one is the model deployment, in which I'm going to leave you to do this, but I'm going to guide you how to do it. So to do model deployment, it's easier than you think. Easier than you think. So in model deployment, you can do it in several ways. You can deploy it in Flask. You can deploy it in Microsoft Azure. You can deploy it in AWS. You can also deploy it in GCP, that is Google Cloud Platform. You can also deploy it in Vercel. You can also deploy it in Heroku. So many processes that you can deploy your models at. Yeah, so you can deploy your model in any place that you want to deploy. So you can deploy, for example, you have the code for Flask here, so you can just copy that code. And the moment that you run it here, you run just it here, and you run this cell. There we go. You can test your data right here. You can test predicts. predicts right here. Let me see if I'm in the right report, in the right path. Predict. So this one is not getting the error, so you just need to check if you have given it the correct routes and paths. So this one should go to predict. I should rename this to what? To one of this one. I'll check and rename. I'll check and rename. Then when you go to that port, it will work perfectly. As you can see, it will keep on running as long as I don't stop it. It will keep on running as long as I don't stop this server. As simple as it looks like. Very, very simple. Yeah, that's it, guys, for today. I know it's running late. We have already covered our 2 hours, I think so. Yeah, so that's it for today's, I think, and I hope you guys have learned something. I think you have learned something cool today. So in the next session on Friday, we are going to be focusing more on deployment. That will be the consultation session, the catch-up consultation session. We are going to be doing more of these deployments just for fun. Yeah, that's it, guys. Friday, yeah, Friday, 10 a.m. Yeah, that's it, guys, today. Hope you have enjoyed. If you have learned something, give me some thumbs up. Yeah, very cool, very cool. Thank you guys for joining. We appreciate your presence and thank you for attending. Have a lovely evening, a good night, and see you on Wednesday at State House, Kenya. Anyway, in case for those who are wondering what State House, why are Kenyans invited in State House? For our Nigerian friends, you can never understand. South African friends, you can never understand as well. And our Ugandan people are in the worst state, so you can't understand as well. But our Kenyan president, sponsored by corruption, has invited us to State House. Thank you. Of course, we are going to. Let me stop this recording. Maybe our CEO can see this and fire me. Anyway, she's a Gen Z.